Hello students, this is Mrs. Raksha Shirodkar from St. Vidya Mandir English High School and Junior College of Commerce and Science. So the same chapter, that is instruction set of 8085 from Computer Science paper 2, chapter number 2. So today we'll be continuing with the logical group. In the last video we had completed total 9 instructions from this particular group. So today we'll be starting with the 10th instruction from this group, that is CMPR is the first instruction in this video, 10th, number 10. Okay, so these 3 instructions are totally different as compared to the previous instructions in this particular group. In the previous instructions we had seen the instruction related to gates, that is logical gate, or and XOR, correct? So in this particular group we'll be seeing the new instruction, that is number 10, which is called as compare. CMP stands for compare. Okay, so we have total 3 instructions for compare. Again, we always have 3 instructions. So see, let us start with the compare first instruction. So the first instruction is CMPR, okay, which stands for compare the register with the accumulator. So the format that I'll be writing here is A minus R. Okay, so you need to learn this. Okay, format is A minus R, where the answer does not go anywhere. I'll show you in the example how it goes, but the format that you will be writing is A minus R. Okay, the addressing mode will be register addressing mode. Now in the next instruction we'll be seeing CPIM, then CPI. Okay, so all of these are compare instructions. So the group is logical group. Bytes will be 1 byte. Since it is register addressing mode, we only require registers. We do not require any operand or data. So hence it is 1 byte instruction. Flags that you need to learn is in this particular group compare instructions. The flags that will be affected are all. So the explanation here is this: in this particular instruction, it compares the content of the given register with the content of the accumulator. Comparison is done by using the subtraction of the content of the register from the content of the accumulator. Okay, and the content of the accumulator remains unchanged. So you need, this particular explanation is a little different, so you need to learn what it does. It compares the content of the, you can write it by your own. Once if you read it, you will understand from the example also. So this compares the content of the register with the content of the accumulator, but the for that comparison you need to do the subtraction. Okay, that is the content of the accumulator is subtracted from the content of the register, and the accumulator content remains unchanged. Now there are 3 rules. See how it does. Okay, there are 3 rules that you need to learn. Number 1, first rule is, if accumulator content is less than the register content, then one of the flag will get set to 1, that is carry flag is set to 1, then carry cy is equal to 1. That way you will write it. So the first rule is, if A, what is this particular instruction? Why are the rules which are mentioned in this particular instruction? Because the instruction itself says compare. So what you need to see is, you need to only check the content of accumulator and register, and the 3 rules that you need to follow. Actually we do not perform any subtraction, but from the format you need to write in the explanation that we perform subtraction for the comparison, but we actually do not do the subtraction operation. Okay, so the rules are: number 1, if the accumulator content is less than the register content, then carry flag is equal to 1. Second rule, if the accumulator content is equal to the register content, then the 0 flag is equal to 1. Third rule, if the accumulator content is greater than the register content, then both of the flag, that is cy and 0, is equal to 0. Okay, now see your example. You can take any example here. I've taken an example as accumulator content you need to assume, and the register R, you can take any register. I've taken L register. Okay, so you can take any register also you can assume any content. So the register content, that is L, is equal to 99H. Accumulator content I have assumed 88H. The instruction that you need to write is CMPL. So what happens from the 3 rule, which is the greater, that is either accumulator or register L is greater. Since from the data that you have assumed, you can see that 99, which is the register L, is greater than the accumulator content. So which rule to follow from this particular explanation? Register is greater. So the rule number one, that is accumulator content is less than the register content. So hence you will be setting the carry flag as 1. Okay. So you will write after execution A is equal to 88H. Same from the explanation I have underlined that particular sentence. Can you see the content of the accumulator remains unchanged, which is underlined. So after execution you will only write A as same, which you have taken or assumed, and the flag you will write as CY is equal to 1, Z is equal to 0. Why? Because from the comparison the carry flag got set to 1 from the rule number 1. Okay, and the other flags you will not mention. Okay, so only these two flags you need to mention, that is carry and 0 in the example. Okay, I hope you all understood. So in the next instruction we'll be seeing, so the rules will be the same as previous, but only instead of register we'll be taking M now, M which is HL register pair. Then in the next instruction instead of HL register pair we'll be taking data, but the instruction name you need to stick into your mind. Why? Because there are many instructions and only 8 or 10 instructions may come in the exam, that is theory paper, which will come from any group mix. Okay, from any of the group they will give you the mix instructions which you need to remember. Okay, so number 11 from the logical group is CPIM, which stands for compare the memory with the accumulator. The format is A minus HL. Whenever you are comparing, always you will be writing in the format as subtraction, minus. Okay, addressing mode is register indirect. Why? Because there is M which is present in the instruction. Group will be logical group. Bytes will be 1 byte. Flags will be all. Okay, then the explanation that you will be writing is, this compares the content of the memory location whose address is stored in the HL register pair with the content of the accumulator by subtracting the content of the memory location from the content of the accumulator. Okay, and then the content of the accumulator remains unchanged. This sentence I have underlined. Why? Because after execution you will write the accumulator content same which you have taken before execution. So the rule is same, only instead of writing the R you will write HL. So rule number 1, if accumulator content is less than the HL pair content, then CY is equal to 1 and Z is equal to 0. If you don't write Z also will be fine. Then second, if accumulator is equal to the HL pair content, then CY will be 0 and Z will be 1. If a third rule, if accumulator is greater than HL pair content, then CY and Z, both the flags is equal to 0. Okay. Now the example that I have taken is A is equal to 88H. Okay, I have assumed accumulator as 88H and HL pair you need to mention as 16-bit first and then 8-bit. So HL is equal to 9900, 4 digit which is 16-bit number. Then that 9900 is equal to 22H. So 22 I have assumed as 8-bit number for HL pair. Now you will write the instruction which is CPIM. From this instruction you will see the content. A is 88, HL is 22. That means A is greater. So which rule? Third rule. So you will write after execution first A is equal to 88H, which is same. Then you will mention the flag, that is CY is equal to 0 and Z is equal to 0. Why? Because my accumulator content is greater than my HL content. Okay, so third rule. This was my 11th instruction. The next instruction will be seeing the last instruction of the compare. So 12th instruction, that is CPIM. CPIM, what happens here? The full form is compare immediate data with the accumulator. I stands for immediate data. Okay. So the format is A minus data. Addressing mode will be immediate addressing mode. Group will be logical group. Bytes will be 2. Why? Because there is 8-bit data mentioned in the instruction. Flags will be affected are all. The comment that you will write is, this compares the 8-bit immediate data with the content of the accumulator by subtracting the data from the content of the accumulator. Okay, then you will write the content of the accumulator remains unchanged. Now again the three rules, instead of writing HL you will write 8-bit data. So for, rules are same, but you will keep on changing what in from the instruction itself. If it is R, you will write R in the this rules. Then if there is M, you will write HL register pair. Sorry, in this particular instruction there is a little change which I have by mistakenly written M. So it is CPI data. So cancel that M and write CPI data. Okay. If there is M, you will write HL in the rule, and if there is data, you will write 8-bit data. Okay. So the rule number 1. First rule is A less than 8-bit data, CY is equal to 1. Rule number 2, if A is equal to 8-bit data, then Z is equal to 1. Rule number 3, if A is greater than 8-bit, then CY and Z both are equal to 0. Okay. Now let us see the example. Example that I have taken is, let accumulator content I have assumed as 58H. Instruction I have assumed CPI again 58, same. So the data 8-bit data also have assumed 58H, and accumulator content also have assumed 58H. So both the datas are same. Then from the rule, which rule to follow? Rule number 2. Since accumulator content is equal to the 8-bit data content, 0 flag will be set to 1. Okay. So after execution you will be writing A is equal to 58H, which remains unchanged. Before execution also it was 58. After execution it is also 58. So A is equal to 58H, carry is equal to 0, and 0 flag is equal to 1. So from the three rules, all the rules we had followed in these three instructions. If you see, only a short mistake in this particular instruction is CPI data. Instead of writing M, you will cut that M and write data, which I forgot to write. Okay. So you need to learn these three rules and the format, which is subtraction, but we do not perform the subtraction. We only compare the two data, that is accumulator data and whatever data that is mentioned in the instruction, either R, HL, that is M, or the 8-bit data. Okay, the three rules. And the accumulator content remains unchanged, so you will write it after execution, accumulator content also, and the flag which got affected, it can be either 0 or carry, and no other flag you will be mentioning in this particular instruction if they ask you in the theory. Okay, so this from this we completed our compare instructions from this group. In the next video we'll be starting with the new instruction, but with the same group. There are many more to go in this particular instruction, in this particular group. So thank you students, hope you all are taking down all the instructions in the notebook and practicing it by writing and example, by taking your own example data, any example that you want. Okay, so thank you students.